Yeah, again, guys, you have two presentations.
Yes, yes.
Algorithm.
However, it will be me now, Ivan Ostromov.
Okay, Ivan, no worries. We accept that.
Mhm.
Algorithm of interference detection of ADS-B trajectory data. Oh my God.
Okay,
Mhm.
yes. Hello, everyone. Actually, my name is Ivan Ostromov, and also today I would like to present you our results of our research team in National Aviation University Air Navigation System Department. And actually, we try to analyze the way how we could estimate presence of jamming in trajectory data of civil aviation. As you know that jamming, maybe it is one of the huge problem in civil aviation. However, before we need to talk about jamming, let me introduce a little bit about the nature of onboard equipment of civil airplane. Actually, according to normative documents in ICAO, each civil airplane should to be equipped with GNSS equipment and inertial navigation system. Actually, GNSS receiver, it is the main source of position of airplane in civil aviation. It happened due to their highest accuracy and their approximately equal distribution of performance of GNSS around the globe. That's why near the same accuracy we have for GNSS. That's why it is a great for civil aviation. And also GNSS provide us the most accurate method for position detection. In case if you have some problems with GNSS, for example, interference, jamming, or maybe some malfunction on board, then onboard equipment should to be switched to inertial navigation system. However, we could not use it too long because errors of inertial navigation system will be increased proportionally to the time when we use it. That's why for a short period of time, approximately up to 7 minutes, we could use inertial navigation system for positioning. And then onboard computer of airplane should to be switched to some alternative positioning methods like navigation by navigational aids. However, these methods provides very poor positioning performance. For example, GNSS could provide us positioning up to 20 meters, and positioning by DME could give us like accuracy in 300 meters. That's why approximately in 10 times bigger than GNSS. What is the problem of jamming or interference action in civil aviation? Actually, satellites, navigation satellites, it's far away from their ground, and its orbit approximately 20 kilometers from the Earth's surface. That's why you could imagine that navigation signal should to follow through the ionosphere, troposphere, approximately 20 kilometers when it reach GNSS receiver. And finally, we are working with a quite poor navigation signal, or maybe quite okay, amplitude of this signal quite small. And if someone would like to interpret you, it could be done very simple because the level of this signal is too small. In civil aviation, there are a lot of cases of unintentional jamming. Actually, we could talk about intentional, mostly it is a military action, and also there is an unintentional jamming when person use jamming equipment. However, they do not want to harm civil aviation. However, it is present due to some reasons. And if you look on the statistic of jamming, actually, if we have fault or lock of GNSS equipment on board, airlines should to report about it to their different international organization. For example, this is a statistic of ASRS, and here you could see that each year we have a lot of amount of unintentional jamming or interference action in civil aviation. Why it happened? Because in the market we have very cheap jammers. This is equipment of jamming, and it cost start from $20. That's why everyone could order it with internet, then put it in your car, for example, or in your USB device and provide interferent for GNSS equipment. Why people use it and why it is very popular? Because these small jammers could provide you like 50 meters for shutdowning any GNSS signals for any satellite constellation. And it helps, for example, for taxi driver to hide their location from the company which track it. And there are a lot of different cases when people around the world use such kind of small jamming equipment and try to avoid some actions from his employed company. However, these jammers could provide interference for airplanes which is on the small altitude. And another reason of problem, because low power jammers could not be detected by radio monitoring stations. That's why our radio monitoring stations in any countries which is a stable network could not detect it because it is a low power and small distance of operation. However, in this case, in this report, we are talking mostly about unintentional jamming, which we have associated with Ukraine. Actually, in Flight Radar 24, approximately half year before, they launched a project for visualization of interference action in civil aviation. And actually, you could see small pictures of affected areas in civil aviation. That's why for 3rd October, 1st October, 27th September, and 30 September. And here, as a red hexagon, you could see the places in which ADS-B signals from on board of airplane. It includes information that GNSS is not available. That's why we could see that there are a lot of cases of jamming out of Ukrainian territory. However, it is associated with the military action because it is only one place in the globe where we've got such problem. And in our research, we try to find an algorithm how we could detect presence of jamming based on data which is available in ADS-B databases. Actually, ADS-B databases includes trajectories of airplane. That's why it is latitude, longitude, altitude, and velocity and heading of airplane. That's why 5 parameters is available for particular time. And many systems use this data for visualization, for safety measurements, for airspace. That's why it is important things. And actually, there is no information about jamming. Actually, if it is jammed, there is totally jammed. It means that there is no particular point in the trajectories. However, if it is not 100% jamming, because jamming could be appeared in different manner. That's why it could degrade performance significantly. And in this case, yes, we need to detect point in which performance of positioning decreased significantly. And to do that, we propose algorithm which is ground on calculating coordinates of next point of airplane trajectory by airplane velocity and hidden angle, and then compare difference between calculated coordinates of airplane and obtain it in ADS-B database. And if this difference is bigger than errors, it means that there is effect of interference because it reduces positioning performance. And actually, by these small formulas, it is a system of equation how we could calculate position of airplane by hidden and velocity. And if we solve those navigation equation, we could obtain a solution for quadratic equation and finally get x and y. And then we just need to calculate the difference in coordinates as x and y, which means like north direction and east direction. And then we could estimate mean square deviation of this error, like this one. Then also we could estimate the sigmas. To do that, we need to apply Taylor series expansion and by first order of derivatives. And that's why we could obtain errors of sigma of x and y axis calculation by errors of time, hidden value, and velocity of airplane. However, it is not easy, just simple comparison of parameters because there is errors of equipment. That's why we also use maximum posterior probability method for classification if it is jamming present in data or if it is just errors of equipment. That's why maximum posterior probability method grounds of bias formula like this one. And actually that's all. Then we try to play with data, and it is a tricky fly MOM 9361, which after our analysis shows a huge tendency to be interferent from some military action. That's why this flight was performed April 6, 2024. And this is the trajectory of this flight, you could see. And this is result, it is just hidden angle and ground speed, also obtained from flight aware database for this flight. And then we apply our formulas and calculate this delta. And you could see that in some cases, delta becomes more than 1 kilometer. And this is the reason to think that it is something terrible happened here. Then we tune our maximum posterior probability method for classification. That's why we use conditional probability density function. And here's a result of posterior probabilities for the values for classification. You could see here is with the values for sigmas, which has been calculated. And finally, okay, this is our delta from previous slide. And here's the result of classification. That's why the blue one here is a probability of correct detection, and the red one it is number of state. That's why if state 1, it means normal flight. If state is 2, it means that it is a condition that errors is too high or errors is abnormal to the ordinary errors. That's why the high risk of interference. And then if you apply this data for our trajectory, you could see that during these red dots, we classified that interference has been present in the airplane trajectory data. And actually, that's all. Thank you for giving me a chance for representing our results. If you have
Absolutely.
questions, I will be glad to answer.
Yep, absolutely, absolutely. So go ahead with the answers. If somebody,
Can I ask a question?
yeah,
So that system gives to pilot a knowledge that we've got interfered, right? Could it lead us to system that could return us to the right trajectory, for example?
Actually, it is a little bit another case. Actually, on board of airplane, we have GNSS receiver. And this receiver give us coordinates, latitude and longitude. And in parallel, we have accuracy. Like accuracy equal 10 meters. Okay. And if it will be interferent, in this case, your accuracy in receiver will be increased like 1000. That's why pilot and flight management system on board of civil airplane know exactly could we use GNSS or not. Okay. That's why during the increase in the errors, onboard computer could detect it easily. There is no needs for all of this methodology. It will be given like as input data. In my case, we analyze the data, just latitude, longitude, and velocity and heading. And that's all. We in databases, ADS-B, we do not have any information about accuracy. That's why we need to apply this tricky thing to detect if airplane has been interferent or jammed in civil aviation. Yes.
Yeah, understood. Thank you.
Mm-hmm.
thank you for the question.